Hey guys, and in this part, let's talk about how to hold information. To hold information, we need this thing we call variables. And inside variables, we need to dictate. If you didn't see my one of the earlier videos, we need to tell the computer how much space does these variables take. And this is really important because it needs to allocate space inside the memory. And again, remember these are electricity, so it needs to tell it, does it need this much space or does it need this much space, right? All these zeros and ones and whatnot. Okay, so based on that, we need to first declare our variables, and while we're declaring, to mention their type, right? This is the important part. Their type is going to determine how big it's going to give us of space in the memory, and this is really important. So there's a couple types you need to know and learn. We're going to do all of those, but you got to understand that if, let's say, for example, we use this thing called integers, we're going to talk about that in a second. We can't put something that's string, some other type, inside of a integer. Okay, why? Well, because let's say, if again, the variables, you could think of it maybe as a box, right? So here I have a box, and inside this box it fits a chair. So I could put any types of chair inside there until they're chairs. But later on I try to fit in, let's say, a couch. Well, a couch is bigger than a chair, so this box cannot fit the couch and it breaks, right? Does that make sense? So the type, if it's a couch or if it's a chair, it matters because the space is given to it is perfectly fit. Sometimes you might not use all of the space, but it's made sure that whatever type of that specific type you put in, let's say chair, it will always fit. Even though there might be a bit of space left over, it doesn't matter, it will always fit. So the type really matters. And secondly, you'll sometimes notice, like here we have a couch, right? A couch is much bigger. Inside the couch, well, inside of a couch, obviously we could put a chair. So you're gonna see that happening as well. Just gotta understand that sometimes the type could fit other types, but sometimes the type is too small to fit something else. So knowing what types are out there, exist, it matters a lot. And now you're gonna say, well, why do we even care about the types? Again, because your computer is stupid, first of all. Secondly, well, we got to the stage where now we determine what type you need during compile time, so you don't need to mention it. This is a lot of people doing that. But the problem with that is, it's not good to just use any type at any moment. We want to be a bit more specific. Why? Well, because sometimes we're going to develop for systems that are super small. So let's say if I wanted, let's not talk about our really high performing computers, but what if I wanted a small little computer thing inside my microphone or inside my watch? And here we got to be delicate. We don't have that much space to fool around to do anything we want. Now you're gonna say, well, I'm never gonna go and develop into those places, or I'm gonna say, what, you could predict the future, but let's say you can and you don't. Well, then I agree with you, but when, let's say on your phone, which is super strong, you have smartphones and whatnot, you're gonna be competing with everyone else for something that's super fast, super efficient, and takes the least amount of space. If you think about it for a second, when your application, when your phone it gets full, you don't go ahead and delete pictures, text messages, and whatnot. Those are precious to you. The thing you're going to go ahead and delete is the application that takes the most space. This is why, if you notice the space that's being used by your applications, Facebook, Instagram, Google this, Google that, whatever those big applications are, they've practically take no space on your phone, and they try their best to not do this. We want to keep the amount of space that we use from your computer to a minimum, and we want to speed it up, right? So this is two major things that is going to be the competitions for being, you know, the elite of the elite, if there is such a thing, to be able to have a functioning application that takes minimal space but is just as efficient or fast as other applications. So this is a goal to have. So again, the type really matters. Now, there's a couple types. Let's go ahead and let's check it out. So again, we always need to stay within our boundaries. In this case, we want to stay within our entry. And these entries pointed out by these curly braces. So last time we learned about printing. This time we're going to learn about creating variables. So to create a variable, you first need to mention what the type is. So let's say we create something called an integer. The second part, I'm going to explain integer in a bit. Second part is to give a name for that variable. So again, remember, these are boxes, right? And you're moving from here to your new place. And your girlfriend or your boyfriend or whatever, they need a tie or a shoe for work. And you go look at those boxes. You don't have enough time to go through all the boxes, but you see there's 7 or 8 boxes with the word clothing on it. Well, shit. You're gonna go through each one of those boxes, or you're gonna get yelled at by your other partner because, hey, you didn't write a correct label on those boxes, right? And this happens a lot actually, where people just name these variables 1 or A or B or C or whatever, and in the end they don't know what is what and what are they doing. So the variable name here, the better you name it, the better it's gonna be for you. Okay, so this is a name on the box, so you remember what's inside there, what the value represents. So in this case, let's say this is the age, and we're gonna give it my age of 120, right? So in this case, an integer is a number that could be negative, that could be positive. It cannot be floating numbers. So basically, you cannot say 1.3 or 1.2. This is a floating number. This is not allowed. You will notice that sometimes you're allowed to put letters in there, A, B, or whatever. And if you saw my earlier videos, this is because in the end, your numbers are going to get translated to zeros and ones, and a sequence of numbers is also representing a sequence of letters. Right, and we'll get there later, and this is called ASCII. For now, just remember that this could be negative and it could be positive. There is a limit to this, and this limit is defined by the amount of bits it has, right? So let's give an example. Right now, integers take space of 4 bytes, right? 4 bytes is, every byte is represented by, let's go on the next line. By the way, if you don't know, // is a comment. Basically, the computer doesn't care about whatever you write to the right of this. It needs to be followed right away. / space / does not work. So, so 4 bytes. 1 byte equals 8 bits. So let's say 8 bits is something like this, right? A bit could only be 0 or 1 as we go down to the computer language. And we said, hey, this is, let's say, 0. And as we added to that, let me just copy this a couple times. This, to make it 1, we just added 1 bit. To do the same thing, to make it 2, we added another bit. We added another bit, which here we can't have a 2, so it goes to the next over, so this becomes 0, this becomes 1, right? And we keep on going. So if we do this, we got 3, we got 4, so let's just, so 3 now we add another bit, and we got that. If we add another bit to the 3, again, we can't have 2s, we keep pushing it to the left. We get something like right? And as you go along the way, you'll notice something. Everything's to the power of 2. To the power of 2. As you go along the route, you'll notice that it's always to the power of 2. And as you go, so, sorry. So, if you go by 2s, you'll notice here we got 2, 4, and it's going to go 8, 16, 32, 64, 128, etc. You're going to go higher. And if you turn all of this on, so give you an example. Let's say all of these ones are turned on. Well, it's easy to calculate this. You just have to calculate the positions and add them together. So in this first one, we notice that this one equals to 1. So this is 1 plus this is equal to 2, so 2. So 1 plus 2, which gives you 3, right? And then this one is 4. So 4 plus 3 plus 1, sorry, 4 plus 2 plus 1 gives you 7 if all of them are turned on. And the last one is 8. So this would be 8 plus 4 plus 2 plus 1, which gives you 7 plus 8, 15. You'll notice that something even cooler. This gives you 15, but the next number is just the next number after 15. So if you ever wanted to know which number is the next one or whatever, you got to remove 1 and that's it. So to turn this on, again, it's to the power of 2. This would be 16. And if you add everything, all of these numbers together, you'll get this number minus 1. So this is 32. All of this will equal to 31. This is an easy way to figure this out. Now, coming back to this. So because our integers are given a 4-byte space, the limitation is going to be the amount of this. So how big does our number go? So in the end, we got to understand that this is 1 byte, 2 bytes, 3, 4. I went a bit faster. 1, 2, 3, 4. So this is 4 bytes. And if we go by the power of 2 up, we'll figure out what the maximum number is. If I turn all of these zeros to 1s, what will be the final value do I get? Right? Another cool thing to note is, well, I understand that, but how do we get minus? But again, you got to remember that computers are really simply made. Just we overthink it. It's actually a sequence of bits that determine if we're this number, let's say. Well, we could do the same thing to determine it's a negative. We just have to say, as an example, there's many other ways of doing this. We got to just say, you know what? The first bit here, I reserve it to say if it's negative or positive. So in this case, if, let's say, a value, let's say this, okay? This is currently 15. But if I turn this bit to on, well, now this value equals minus 15. If I take off the first bit and I put it back to 0, it's plus 15. Right? So we reserved one of the bits to enable us to do something as negative. Again, all of these sequences is fictitious. It's something we decided on. We could have decided on any different ways of that we like. Just this way, it's kind of ideal because we could calculate it. We could come to it. It's nice, right? And one last thing to note is if we use this one bit as a sequence to determine if it's negative or positive, well, we have 1 bit less for our total amount of positives and negatives, right? So that's something to also consider. Any questions? Well, there's no questions. So moving on. Now, having integers as one of the types, that's good. We could store numbers. This is when we are declaring and initializing. We initialize it with the equal sign. In this case, whatever's on the right will always go to inside the left, so inside the box of H. we could change the value by just typing that variable name, the box label, whatever you want to call it, and set it to something else. So let's say here, if I do a print and I say age, here it will go and fetch inside that box, go get the value of age and show it to the console. In this part though, we're saying go change the value of age and make it equal to 2. I don't care what was inside, but change it to 2. And if we print it out again, you'll notice that now we're printing out twice age, and in 2 times the value should be different. So the first time 120, second time 2. First time 120, second time 2. Right? Notice that if we add a box with the same name as another box, a variable with the same name as another variable, well, the computer's gonna say, hey, no can do. You might do shit in your house, but you're not gonna do it in my computer. So you can't have 2 boxes with the same label because, again, the computer's gonna get confused, you're gonna get confused, and it's not gonna work out. So when you're gonna create something, you're gonna mention the type and then the variable name and initialize it. But when you want to change the value, well, you just need to tell the computer, hey, go into that box I already created and change the value to 2. Right? And you could do funky stuff with it. You could also say, let's go further down. You could also say age equals age plus age multiplied by 2. So in this case, first thing it's gonna do, it's going to do the right side of the equal sign. It's going to replace all variables with the value being mentioned. So all of these variables are becoming 2, 2, 2. Then it's going to do the mathematical order of things to do, such as multiplication before, plus, and negation and whatnot. Right? So the first thing it's going to take is these 2. 2 times 2 is equal 4. Then it's going to go from left to right. 2 plus 2, 4. 4 plus 4, 16. So the final value should be 16. Let's go test it out. Undo, undo, undo. We run it, and we're going to do another age. So it should be 120, 2, and 16, or 8. Let me see here. 2 times 2, 4, plus 6, plus 8. How? Oh, okay, 8. I don't know why I went to 16. I was multiplying where I shouldn't. So 2 times 2 is 4, plus 2 is 8, plus 2 is 10. I was multiplying at some point, and that gives us 8. Cool? Now, let's go further. So you have int for integer numbers. You also have float for, let's say, the grade. Float allows you floating numbers. So these are numbers where they have a dot at the end, right? You'll notice it's giving me a mistake. It's because it can't determine what this number is. There's actually 2 types of numbers that could hold floating numbers. There's the first one, which is a float. You'll have to mention it with an F. You could actually mention the integers as well. I think it's a I or a number. I can't remember which one it was. I think it was an A. Anyway, they have specific things, and depending on your language, you might have to specify or not. Anyway, for floats, there are values that could be stored after, such as 12.20 or 7, etc. There's another one that's similar. It's called double. And this one is when you want to be more precise. By precise, I mean you could do something like this. Why can you do better? Because double is double the size of a float. A float is, again, 4 bytes, but a double is 8 bytes. And with 8 bytes, you got more values you could enter. But again, this comes down to how we did the negation. How do we store how do we store this much into it? How do we decide what's a floating number or what's a whole number? Well, again, we have, this is 1 byte. And in this case, let's say we have 2, 3, 4 bytes. Inside of a 4 byte, at some point we gotta say over here, after this, anything before this is gonna be considered our floating number. Anything after this is gonna be considered our whole number. We could do this, and this is what they did. And when we got it with a double, well, now we got double on each side. So with that, we got more precision, right? So our double will allow us to have more precise values than our float numbers will allow us. What that max number is and whatnot, you could either Google it or calculate it yourself. Yeah. So these are good to know. And again, you'll notice the double doesn't require the F at the end, but you could always mention it with a D, even though D is a letter. In this case, this is just for the compiler to understand that this number that you're mentioning here on the right side is a double. Well, you're gonna tell me, well, I mentioned it here, why do I need to mention it there? Same thing with float. And again, it's because the computer is stupid. It only does as much as we made it to learn, or we made it be able to do, right? Think of it as a little kid. If you don't teach the little kid to do something properly, it's always gonna do whatever random stuff he wants. Some adults are like that, idiots as they can be. So the more you teach them, the better they're trained, the more they could do without assistance, right? So float and double we got, that's nice. There's some other types. These are called primitive types. I'll actually type it all here. All of these are called primitive type. It's basically types that always will exist, is part of your OS. Another one is characters. Let's call it, let's say if we wanted to represent your sex, it's either male or female or A or transgender or whatever there is. I don't know all of them. You could represent them by one letter. If you put 2 letters, it'll get a mistake. Notice that characters are surrounded by these single quotes. If you put double quotes, it's not going to understand it. It's going to believe that it's a string. Again, if you run a higher language, this wouldn't matter so much. But because we're in the lower language, it doesn't know yet, or it doesn't want to learn, or etc. There's a lot of reasons that goes into making this. So all of these are primitive. We have integers, float, double, characters. We even have bytes. So let's say int size equals 4, right? We have booleans. This is an interesting one. Is the sky blue? So this could only take a value of true or a value of false. So these are nice to figure out. So true or false. Notice that it's lowercase. And again, remember that when this is translated into zeros and ones, uppercase T and lowercase t are completely different numbers, different sequences of bits. So this is important to know. True, false, also represented by 1 bit, right? Which 1 equals to true and 0 equals to false. And again, you'll do this enough time that all of this will make sense. But just for now, remember the types that are being shown. And the types keep on going. There's millions of different, well, there's not millions. There's a bunch of different types that exist. I think there's around 16, 17. But the major ones are these. A lot of times you're going to see people saying string. And let's say that's my name, and that equals to, let's say Reza. Right? Notice a string is basically a character. Notice the string is actually not orange either, like the rest. This is because this is not a primitive type. This is a type that was invented by using a bunch of characters together. So in the end, this is something we call an array of characters. So this is not a primitive type. This is a really useful type, but we'll get back to it later, especially we're going to create our own later and make fancy stuff. But for now, This is an array of characters, and we'll talk about arrays later. And another cool thing that we want to see is one thing is your IDE shows you something really nice. It's all grayed out. If you notice the gray, it's basically saying your variable is not being used. While we look over here, age, because it's being used everywhere, it's actually not grayed out. Right? So let's show that. So let's say if I want to print your, let's say your grade, I could do something like this. And you'll notice grade is being used while that's not. Again, IDEs help you to code. Another thing to note is if I add grade here and I add 90, it will do this, but because it's not being assigned, there's no equal sign in there, the value that's being shown is going to get lost afterwards. So what I mean by this is the value of grade is never going to be changed. Even though we're doing plus 90 here, the next time around it's going to just show 12.4. Right? So you could do a lot of these things with them until you don't assign it, it's not going to change the values. Cool? I think this is enough for now, and we'll continue off in the next video. Cheers.